to welcome Dr. Sarah Lehman. Is that how I pronounce your surname, Sarah?
Yes, like layman's terms, yes.
Gotcha. So Sarah M. Lehman, who is joining us from NASA. Sarah joined the Safety Critical Avionics System branch at NASA Langley Research Center in December a couple of years ago. And Sarah's work focuses on the testing and verification of machine learning systems, but she has additional research interests in AI ethics and human factors involved in mixed reality. Sarah's background is in computer science. That's what you earned your PhD in, as I understand it, Sarah, where your educational background comes, but sits exactly at this intersection between ethical concerns and the technology side of it that we're wanting to explore here. And Sarah, as I understand it, you're going to talk to us about some ethical questions concerning privacy that emerge kind of bottom up out of some of the practical applications that you and colleagues have been developing. So please take it away.
Thank you so much. I'm very excited, so excited to be here. Yes, my topic for today will be taking a more direct look at the kinds of privacy invading opportunities that are available as a result, a direct result of the technological developments of current commercial offerings. So we're specifically going to be looking at mobile devices, commercial mobile devices, and commercially available AR, machine learning, computer vision types of libraries that from a software engineering perspective really enable these threats. So the overall talk, we're first going to define what we mean when we say mobile augmented reality and how that differentiates from the kind of high level view of AR that we've been addressing in workshops right to this point. Then we'll specifically be looking at the breadth of mobile AR security concerns, and then dive into our specific threat, which I have dubbed hidden operations. So through the hidden operations threat, we'll step through the adversary model, how you can modify a more or less honest mobile AR application to include malicious logic, and then do a more technical comparison of an honest versus a malicious app and demonstrate that it's very difficult to tell them apart. Our final thoughts will involve user education and communication, as well as potential research directions. So when we say mobile augmented reality, so far we've been talking in kind of the high level abstract in our workshops about augmented reality systems and what it means to impact a user's experience of the real world. But specifically, mobile augmented reality looks at is dependent on the hardware that the user is using to engage this AR system. So we're talking about smartphones, we're talking about tablets, we're talking about increasingly self-powered headsets, but the idea being that the user is able to move around their environment freely, and they're not just stuck in one place because they're tethered to this big computer system that has to run all of the operations. So in this paradigm, we now have to worry about long-term use of environmental sensors and machine learning operations in a open-ended context of usage conditions, as well as the concept of a bystander. So somebody who is just out in the world minding their own business, and now you are potentially capturing them in your AR session. And finally, the potential for new data leakage and data abuse opportunities, even if your system is more or less honest. Within the mobile AR app ecosystem, there are many different places that you could leverage this unique access. So you could be an end user who is misusing the application in an unexpected context. You could compromise the device itself. You could be a bystander who is incorporating actions or elements of the environment that manipulate someone's AR experience. You could compromise the library itself, which the developer was using to create this app. You could be You could compromise the network connections. You could there's lots of different ways and lots of different attack points that a malicious developer could leverage. And the opportunities to abuse user trust then expand as well. So the question is, if you are a person who's in charge of rubber stamping new applications to say, yes, this is appropriate and honest for user consumption, how do you identify when an AR app that is up for consideration, say for the App Store, to be published on the App Store, how do you identify when such an application is performing a dishonest or hidden operation under the covers of an otherwise honest AR app? So in this situation, we're defining a dishonest operation as any sort of vision or machine learning based operation that is outside the scope of what the user would reasonably expect the application to execute. So we have here an example vision-based AR application. So, and just for simplicity, I'm going to be using in my examples vision-based AR, but obviously there's, audio, there's haptics, there's many other aspects, but for simplicity, we're using vision. So in this situation, the user has their tablet up or their phone up and they're shopping for new home goods, right? So I have a big empty wall and I want to put new wall art on there. And I found this painting that I really like, and let's see how it looks on my wall and where I might buy it and what local stores are offering this painting. So the observable expected operations may be, for example, to identify vertical planes or horizontal planes to place the furniture in your home, as well as the actual placement of that virtual object, and then a hovering label to display prices. But what you don't know is happening behind the scenes is that those images are also being scanned to identify potential socioeconomic markers, such as what laptops are in your home, what handbags are in your home, are they brands that are recognizable, and thus inferring additional statistics or demographic information about you that you did not realize was happening. These hidden operations, your knee-jerk reactions, well, surely we can catch those. Surely what we're doing with mobile app publication processes and permission structures and all these things are doing something that could catch these apps. And the short answer is no. So current permission structures are generally for mobile devices, for applications you're installing on those mobile devices. You will be prompted when you first install the app for any necessary permissions, such as access to the camera, access to the GPS, and that only happens once when you first install, and then never again. And currently, no major mobile OS developers, publishers offer machine learning specific permissions. So you just have sensor level, so camera, GPS, microphone, etc. You also won't necessarily get flagged by a network traffic monitor because there's many workarounds that you could do to avoid offloading large data sets. There's also plausible deniability in the case that you have to offload any large number of camera frames or video snippets or whatever, that you could potentially make a business reason or excuse that you would need to offload this information. And then finally, once data is offloaded off your device, you have no control or accountability over what's being done with it because it is now on your app developer's remote server and there's nothing you can do. So in this world that we're building, this vision that we're building, who is the actual attacker? Who is the malicious actor here? In this case, we are targeting, and again, remember that whole big map of vulnerabilities. We are specifically looking today at the developer himself or herself or themselves. So in this situation, they are either actively malicious or just incompetent. Either one is supported here. What they are doing, they are obtaining and offloading augmented reality specific data without alerting the user, either because they are deliberately not telling them or they forgot to tell them. And this is used to learn about the user and their environment, and is presented as an otherwise honest application, giving some sort of unrelated utility to the user on the surface. So in order to make this happen, I first want to present to you how this could occur. And this is a big component of the threat, in that where computer vision and machine learning logic was to actually develop it and create something that was going to be useful, previously required a lot of in-depth, very specific knowledge on the theory of computer vision and how to get these functionalities developed and pulled together. But now, because these mobile device and operating system publishers are capitalizing on the interest in AR, now these libraries are becoming increasingly encapsulated, increasingly integrated into those systems, and that barrier to entry is dropping all the time. So on the right here, we've got a little graphic showing the trade-off between what I call simplicity and configurability. So in this first category of libraries, we call integrated AR libraries. These are the ones that are specifically targeting a particular device, and specifically mixed reality functionality on those devices. So that's AR Core if you're using Android, AR Kit if you're using Apple. The mixed reality toolkit for HoloLens, Vuforia is another library. These have very, very low learning curves, and you can add AR functionality to your application in almost no time. The trade-off in this simplicity is that it's very low configurability. You only get the functionality that that library offers. So like plane detection, if you wanted to, you could upload, so for example, a 2D image of the QR code, and now you can recognize that QR code. So in a very few lines of code, you can add these basic functionalities, but if your library doesn't offer it, you can't get it. The next level up, that kind of splits the uprights between simplicity and configurability, are function level vision and machine learning libraries. So this is like Google's ML Kit or their image recognition cloud API, where you have more specific, more powerful functionality, but you have to have a little more software engineering experience to be able to integrate with their API. Any recognition, any actual machine learning that happens is handled by them, and you just have to provide the data and then respond to the results of those operations. So kind of splits the uprights. Finally, you have more general purpose vision and libraries such as TensorFlow, OpenCV, scikit-learn. These are the more theory heavy, so incredibly configurable. You can get them to do anything that your mind can imagine, but it requires a lot more in-depth knowledge of the theory behind vision and machine learning in order to develop a model that's going to work and perform the task that you want. So in this case, your only limitation is your knowledge and ability, but once you conquer that, you can do whatever you want. Now, these three families of libraries all kind of break down into the same three steps, and then what the specific implementation looks like changes slightly. So on the top here, you've got these three very broad steps from a software engineering perspective. You've got your input, you gather data from your sensors, you've got transformation, which is performing the actual machine learning operation you're interested in, and then output, whatever haptics, audio, visual that you're providing. For an integrated library, the library itself is in charge of connecting to those sensors, whereas for a function level or general library, you are in charge of doing that. For the transformation, the integrated library will take some sort of like pre-made object file that you provide, such as, for example, a 2D image of a QR code. Whereas for the function level or general purpose library, you have to actually provide data that it would learn from. And finally, the output is the same your app is, the core logic of your app is responsible for providing any augmentations that you require. So that's your general app building approach. It's not that different to make it malicious, to add extra stuff. All you need to do is add some additional extra recognition materials. So here, what's outlined in red, and then maybe some new response logic, which is outlined in orange. I probably should have picked more contrasting colors, but that's all right. And those two aspects, that's it. That's all you have to do. Once you have the framework in place, it's just modifying those slightly. And now you've got a whole new range of machine learning functionalities just by adding some additional 2D barcodes, or by adding, you know, a little extra, some additional labels that you're interested in getting out of your function level library. So from this section, the ultimate takeaway is that in and of itself, the AR functionality that you're using is not inherently good or bad. What it comes down to is your developer intent and user expectations and how well those two jive. So we, as Ben said, we looked at some more empirical kinds of comparisons. We developed 3 different applications, one that we called honest, one that we called the complementary hidden, which is where the hidden operation leverages the same functionality and general results as the honest logic, and the orthogonal hidden, which in which the hidden functionality was completely independent, had nothing to do with the original honest functionality, and ultimately trying to tell, can we tell the difference? Can we tell which app is which if we don't already know? If all we're doing is just looking at the artifacts, the software, how it runs at runtime. And I'm going to skip over this a little. I'm going to skim it. But basically, you know, we looked at the permissions. Permissions were the same. We looked at the manual inspection of what artifacts are inside the app package. The complementary hidden had some additional ones, but the orthogonal had no additional artifacts. Again, complementary hidden had some additional artifacts, some additional assets. Orthogonal hidden had none. There's no definition, no distinction between the runtime UI for any version of the app, because Android does not require you to provide any visual indication to the user when you're doing machine learning. You don't have to if you don't want to. So there's no difference. We implemented some runtime stress tests. Ultimately, what it comes down to is stress testing works some of the time, depending on what you're doing. Some conditions work for certain operations and some work for others. But what it comes down to is you can hide those if you want. So yes, in the situation where we developed the apps ourselves and knew what we were doing and weren't explicitly trying to hide our footsteps, yes, we could force a difference in runtime resource consumption. But ultimately, any malicious actor who is trying to do this without one's knowledge can conceal this. It is concealable. So final takeaways, and then we'll talk about some potential research directions. We are in a particular tipping point in terms of how small, how concealable, how powerful our mobile devices are, and how much they are capturing if you are using the pervasive sensors associated with augmented reality. You're using the camera, you're using the microphone, you're using these things, and now you're capturing even more data than ever before, in combination with these incredibly powerful, easy to use vision and learning libraries. And it all comes down to, effectively, what your users are expecting and how well you do or do not communicate what you're doing with them. There is no quick and easy way to tell when an AR application is running these hidden operations, either intentionally or accidentally, because they're running what operations they're running, and whether or not they tell you or whether or not you figure it out is kind of secondary. If you have an actually intentional malicious developer and that developer has some level of skill, there are a range of strategies that they could use in order to keep resource consumption down while on device, while still performing their hidden operations. You could also just completely bypass any onboard monitoring that you may be doing by just offloading any data that's interesting to a remote server, and then the world's your oyster. So ultimately, it comes down to what we can do to improve end user communication and understanding. Do your users know what you're using vision and learning functionality for, and why? And how do we enforce that? Now, you could just say, just give the user all the information and let them decide. But mobile device users are notoriously bad at understanding permissions requests from their applications. And you get notification fatigue, you just click yes, 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 shut up, yes. And just get through whatever prompts so that you can actually use the app. However, even if they did understand preferences on these potentially privacy invading functionalities and sensor access are highly contextualized and prone to changing over time. So it could depend on where they are, what time of day it is, who's with them, what they're doing in that place, that all affects how and when and why they would give permission to perform these operations. And as previously mentioned, the contemporary operating system publishers, their means of requesting and enforcing these permissions do not adequately inform users of what's going on and why and all of this context, or allow users to adapt and change those preferences over time. As previously stated, it's just a binary. You just hit yes or no when the app is installed, and that's it. So where can we go in the future? I can see three primary directions that this group, I think, would be interested in. Specifically, first, in further investigating how the context sensitivity of both users and bystanders' privacy preferences in the presence of various AR functionalities changes. So there has been some work so far in the computer science community in terms of pervasive sensing as a whole. So from just general access to the camera, general access to the microphone, not with a specific AR focus in mind. But as we've observed in previous workshops, all of the potential that AR has to impact your understanding of the world around you, it has a lot of potential impact to what folks are doing and experiencing. So looking into how people feel about that, especially in a multi-user environment, as time goes on and depending on where they are and what they're doing. Second is looking into new paradigms for how we can request permissions on mobile devices that are sensitive to the context in which they're being used. So how would a normal, and when I say normal, like not super tech savvy mobile device user, how would they prefer to be alerted to when these operations are happening and when and where and why? And then finally, if there's interest, formalizing an ontology or a hierarchy of the capabilities of these different kinds of libraries and looking into how we can assign privacy risk scores or some sort of breakdown that would allow us to more rigorously talk about how these different capabilities can impact privacy and data sovereignty from a user perspective and from bystanders perspectives. So I just rattled through so much because this talk is normally an hour. I would, yeah, that was like 25 minutes. So I definitely did rattle through pretty quickly, but yeah, I would love to talk more. This work was done prior to me joining NASA. So that's why this is all my personal information on here. But my current research at NASA is looking at test metrics for neural networks. So if you've got a neural network that is being integrated into an aeronautical system, into aircraft, how do you develop testing procedures, metrics, bodies of evidence that can then support a safety assurance case that this component is safe enough to put into the national airspace?
Wonderful. Thank you so much, Sarah. That was incredibly fertile and thought-provoking. Met
There's a
the
lot going
brief
on.
exactly. I feel like my table is getting nicely filled up with ethical concerns and things for us to attend to over the course of the meeting. Let's throw it open to questions. Perhaps you could stop sharing your screen if that's okay.
Sure.
People who want it can have access to the PDF in a separate window by clicking on the link in the chat. And let's move on to questions. Once again, raise your hand if you want to, or ask me in the chat. Fiona, go ahead.
Thanks, Ben. So I think that I am coming to appreciate that I don't understand some. Is Chris Mills still with us?
Unfortunately not. I think he had to teach. Is that right, Laura?
Okay.
So I think he's gone.
I hadn't realised he'd gone. So I feel that I don't understand something that's happening in this workshop. So I loved your paper, Sarah. It was like, it spoke to me of a huge important problem that the likes of us should be paying lots of attention to. But at the same time, I worry that Chris Mills warned us about something which I don't really now know how to make sense of. So Chris Mills said, well, when we're looking at potential problems, we shouldn't just look at, we shouldn't just say, well, it depends how a technology is used, like we shouldn't focus on that. But yet that was clearly a huge focus of your talk. And I don't know whether I'm missing something here or whether the two things are perfectly compatible, or I just don't know, in the light of what Chris said, or maybe in the light of what you said, which all seems so relevant and important, what to make of it. We're not really interested in cases where someone says, depends how it's used.
Sure. I guess, like, as my dad would say, that's why there's chocolate and vanilla, right? But my whole job is focused on these very, very specific applications. It's the whole point of what I do. So I very much respect Chris's perspective on this. But obviously I'm going to push back. And really, isn't that the case for everything though? It depends on how it's used, literally any example. You take this and it's a great little mug, or you can throw it on somebody and now you've ruined their day. It depends on how it's used and how much iced coffee you actually want in your body. So yeah, I guess that's about my only rebuttal on that.
Yeah.
May
I, since Chris isn't here, maybe I could attempt to kind of reply partly on his behalf, because I think these methodological questions are sort of interesting. I think it seemed to me that what Chris was warning us against was not so much having a form of reasoning that leads to a conclusion of the form, it depends on what you're doing with the technology. It was rather that he was warning us against a way that people can do applied philosophy sometimes, which is either to sort of to see it as a business of just really, we philosophers sit on top of the mountain and we work out the truths of the great ethical theories. Maybe it's utilitarianism, maybe it's deontology, something else. And what we do when we're applying it and thinking about talking in this type of context is we bring the tablets of truth down the mountain, and we, using our skills of logic, tell people what the logical consequences are of that for a particular domain that they're talking about. So utilitarianism
Oh, no.
tells you,
Okay.
on the whole, what you'll get is just a sort of boring set of implications of those core ethical theories, but it's not philosophically very interesting. It's not really connected to what people are doing. I think, or what you do is you apply a kind of philosophical standard for success to your inquiry by saying, look, we're only going to look into this if something distinctive and new on the philosophical level is what we get out of it. So we think it's a failure, for example, if we look into the ethics of AR and discover that actually, well, there are other forms of deception that have some of the same problematic features, or other forms of manipulation that have the same problematic features. I took it that one of the things Chris was saying was, look, if what we were wanting to come up with was only theoretical philosophical contributions, then maybe that would show that it wasn't really worthwhile thinking about it. But that would still be embodying this kind of coming down the mountain conception of how philosophers can talk. What he was offering instead was what he called reflective equilibrium, alluding to kind of John Rawls's way of thinking about it, where what you have is a kind of going back and forth between particular judgments that arise in particular concrete circumstances and evaluation of general principles, where there's no antecedent presumption that one direction of fit is the way that you go to get a successful inquiry out. So one thought there is you think about your general theories, you think about general wrong-making features of scenarios. I take it that's what Chris was doing, and then try to draw some practical lessons from that. But I think it's quite compatible with that to think that also what you might do is think about particular applications or particular practical conundra that arise from something you're trying to do, and then kind of work your way up to kind of general ethical principles from there. I mean, whether there's a determinate way of working out the outcome of that kind of inquiry, I don't know. I think maybe I'm less sort of optimistic about this than Chris is, but I took it that the kind of bottom-up sort of practice first, then start thinking about systematization approach that Sarah was taking, which is sensitive to context, is kind of compatible with the general methodology that Chris was presenting. That's what I think he would say anyway.
Thanks. And I just wanted, because you've been talking, I don't know how much attention you paid to the chat, but Joshua sort of wanted a follow-up here, I think.
Yeah. So I agreeing with everything that you just said, Ben. I think it's a separate point. So what Chris had in mind, I think, was somebody studies the use of VR and they say, oh, it, kills people's social relationships. And then somebody else says, well, it depends how you use it. And that's true. I think Sarah's point is an entirely different thing. It doesn't have any, she's not talking about how you use the device. She's talking about how the device is designed. So the dangers that I thought she was pointing to are dangers that are intrinsic to the design of the device, irrespective of how you're using it. So the 2 points are entirely compatible. One is a point about a worry about that the designers of devices should be concerned about the vulnerability in the device, which is orthogonal to its use. And the other is this, I think Chris is absolutely right, that there's this kind of don't complain about AR or VR, in very general terms, because it depends how people use it. And yeah, that's true. I just think that these are, I think both points are true, but I think they're focused on very different issues. Is that, Sarah, does that resonate with?
Yeah, maybe the question is, or the refutation is, it's not how you use it, it's how well your users understand what you're doing.
Yeah.
And why.
Yeah, that's a better way of yes, that's yeah. And but just one other thing, it's how but you know, you could design the device so that the users don't have to understand it all that well in order to be protected against the kind of vulnerabilities that you were describing. So
for sure. And obviously the computer science community, like if you can get through a day without looking at anybody in the eye, it's a good day. So, you know, if you can kind of head off any potential reliance on the user and their understanding through a technical means, then the computer science community likes that. But from an ethics perspective and from a humanist perspective, looking at ways to improve end user understanding, societal understanding, because even if you're not the user, you could still be a bystander. And what sorts of capabilities and potentially privacy invading capabilities these kinds of systems have.
Thanks, folks. That was really useful. I guess because it was originally Fiona's question, I just want to go back to Fiona to see whether these irenic maneuvers by Sarah, Josh and me have sort of assuaged your worries a bit.
No, they haven't. So I think that I still feel that I'm not convinced by the thought that there aren't. I suppose I worry that we could restate the concern. It's not how the user uses this technology, but it's how the designer uses this technology. So we're told of this certain computational architecture, and now is that architecture good or bad? Well, it depends what the designer does with it. It depends whether they build the library in this sort of way or export the data in this sort of way, and whether they tell the person in this sort of way. So I mean, this is not my area of expertise. I feel like I'm very much feeling my way along here. I just think that we should I worry we should just ignore Chris's point. Like, this is just a thing. Like, how you use it doesn't stop us thinking through.
You can build Fiona, you can build a more privacy protecting architecture.
Yeah.
I mean,
I agree.
I have lots of colleagues. I work at Apple. I have lots of colleagues who spend all their time building more privacy protecting architectures, and they are orthogonal to the issue of how users use the devices. That's what I'm thinking about. So I think
I agree with that. I agree with that point. I just think
that's where Sarah's, I think, focus is I think it's about the design of the about device design.
I think that even when you focus on that issue, then there's still questions of depends how you use it come up.
No, that's right. No, Chris's point is right, that whether it's good or bad for you depends how you use it. But you can build a device so that it's more or less vulnerable to the kinds of privacy and security issues that Sarah is concerned about. And one view about this is that you build strong privacy protections into the device. Okay, then you still have these issues about whether you're using it in an antisocial or pro-social way, whether it's causing you physical damage, muscular skeletal damage, all that stuff still comes into play, but you built it into the architecture that this particular vulnerability is diminished, significantly diminished. That's so, yeah. Sorry.
So maybe, and I'm not, this is not, I don't have a brief of defending Chris here. And also I know Neil and Max have been quite patient, so I suggest we should move on. But I have one final thing that I wanted to say to put this in the context of what's going to come afterwards in the workshop series, Fiona, which is, I think sometimes those of us who teach ethics are particularly familiar with this. Sometimes the conclusion, well, it all depends, or it depends on what you do with it, or it depends on context, is a kind of conversation or inquiry ender. What it represents, it's a kind of acknowledgement that there's nothing systematic or principled that one can say. It's just sort of it's a kind of lazy conclusion. Oftentimes when our students sort of say that, what they mean is, look, I give up on trying to come up with what I really wanted, which was a nice, clear, categorical statement of what is or is not allowed, or what we should or shouldn't do. And I think that I can understand the frustration that people feel in that type of context, but it depends upon us agreeing that what the object of our inquiry was supposed to be, or the endpoint of our inquiry was supposed to be, was those kinds of neat, simple, categorical statements, sort of saying, right, a technology of this form is never permissible. Technology of that form is always good. We should never do this. We must always do that.
That's tremendously helpful, Ben, because I wouldn't want to go down that route. And if that's what's being warned against, then I'm all signed up to it. I think I was understanding it a bit differently.
I think so, but I mean, it's useful for our purposes as a group because it tells us something about the shape of the guidelines that we might want to come up with in the longer term for guiding this technology. Because I think the temptation, especially from policymakers, to come up with really simple, universally applicable rules is going to be very strong. And I think one of the things it might be important to articulate is that that's not quite the right way to go about it. It's thinking that you can sort of come up with the right set of beliefs somebody needs to have to be able to consent sort of in an informed way or something like that. That's just not the shape of the regulation or the guidelines that we'll have. What we'll instead get, I guess, is a series of good making and bad making features or something of that sort. And I take it that that's exactly what came out of Sarah's talk today, is that sort of you can't come up with a nice algorithmic way of distinguishing between the apps that are doing this honestly and the apps that are doing this dishonestly, whether maliciously or accidentally. What you have to do is to drill down into the particular architecture and try to work out how that matches up with these messy contingent facts. Now, in some sense, that means it all depends, but of course it's saying it all depends in a way which starts an inquiry rather than finishing an inquiry.
Brilliant. And I found Sarah's comment in the chat incredibly helpful too. That was
my
my worry, that you can't ever get away from it depends, but that shouldn't stop us. But I think we're agreeing now. So that's great.
Yeah.
Thank you. And thank you, Sarah.
That was super useful, folks. Neil, you've been very patient. I'll take your question now.
Yeah, thanks. I think it's a lot to debate there, Ben. Certainly that the context is important. Helen Nussbaum, one of the sort of authorities in the privacy areas, talked about privacy in context. So we can't lose context. And I think there's a lot of issues to be explored there. But to ask some questions of Sarah, perhaps. Firstly, how could this be looked at in terms of privacy by design? And secondly, it doesn't all depend. It will be influenced by the ethics of the community. And I see that a lot of the work is open source. So TensorFlow is open source. Do you think the ethics of that open source community can affect how the ethics of AR are considered?
Fantastic questions. So as stated in the beginning of the presentation, one of the potential attack surfaces is the library itself. And yes, by having those libraries open sourced, or in the case of larger publishers, you have like some modicum of trust in them, that at least individual malicious actors aren't compromising them. So that does help protect against that particular surface, is social pressure on these big publishers like Apple, and then the community eyes on open sourced libraries. That does help a lot. In the paper, we talked about we spent most of the paper going through, the one that I've linked in the chat. We spent most of that space going through the specific technical comparisons of these different applications and talking about the implications of, if you don't want to, you don't have to have these extra artifacts. If you don't want to, you can avoid spikes in resource consumption, blah, blah, blah. But at the end, we do talk about potential design changes, how the application, specifically like the vetting process for app marketplaces, the app store, could change to provide more privacy from the get-go, from implementation time. So for example, if you are developing, let's say, a general purpose library, such as with TensorFlow, and you want to say, recognize different breeds of dogs, And so you've developed this network. This is what you're going to use. Actually, let's do plants. Let's say you're developing this app that's going to help you diagnose issues with your house plants, right? So you've developed this network. It categorizes all of these species of plants, and you submit that network as a separate deliverable to the App Store. And they verify that network and whatever data and whatever like metadata that you use to develop it. And then maybe they rubber stamp it. Maybe they have some sort of key that says like, this is approved. And then when you submit your application for publication, as part of the app that gets published, it has to match, that neural network has to match, that model has to match what they have already seen and validated and tested. So maybe that's a way that you can help to kind of corral the potential for misuse of these kinds of things. But honestly, I ran out of time to go look at that other stuff. So it's more speculation at the end of the paper, because I got a new job and they told me what to go study.
We might need to get you back to talk again, Sarah, when it comes to sort of thinking about the nitty-gritties of how we actually operationalize some of these standards. I think that sounds great. Max, you've been waiting a while. Your question now.
Thanks very much. Thank you, Sarah. So I'm Max. I'm a philosopher working on the ethics of AI and also consent. And I was very interested in something that you said at the end, namely that we should be sensitive to different ways of asking for permission, user permission, and sensitive to how different people might want to be alerted to different things. And I think that's a great opportunity maybe to connect it back to some of the things that Chris said. So it seems that you're saying there's an ethically valuable way of framing information and alerts and requests, something that is kind of individualized to a particular user and enables them to make a more autonomous or better informed choice. But on the other hand, we have that risk, that ethical risk, that framing can also be manipulative. So I'm going to ask probably an extremely annoying question, but do you have any ideas how we can kind of strike that balance between individualizing in an ethical, valuable way on the one hand, but avoiding manipulation on the other?
Sure. So there has been some pretty hefty research done in the computer science community on preference learning, basically. So if you were to, instead of having this very binary permissions structure, if you had some sort of like companion app, and again, for trust reasons, let's say that it comes from your device manufacturer, it comes from your OS publisher. It's not Joe on the corner. And it starts out by asking you, and like all your different apps register, you have these different flags that get raised. And it's like, hey, I need to, thank you, Josh. It raises, like, hey, I need to use the camera. Hey, I need to run this machine learning operation. Hey, I need to do whatever. And so you start out with a lot of these prompts. And then over time, depending on like all of this extra context that your phone is able to collect or your device is able to collect, it starts to guess like, okay, maybe I don't need a prompt this time because I'm pretty sure I'm going to know what their answer is. And then it decreases over time. And some of those kinds of environments and those kinds of experiments, I actually linked in the references section on my slides. But yeah, those, as far as what I've seen, have been more like the contextual privacy preferences of just phones as a whole, and the kind of sensing and information that phones and mobile devices can collect as a whole, and not specific to AR and how it could potentially impact your perception of the world.
That's very helpful. Can I just ask whether that particular proposal implies the view that a person's past choices and yes and no clicks are ethically representative, that what they said in the past could be perpetuated?
No. It's just behavior, historical behavior, making guesses off your historical choices. That's all.
Okay, thanks.
It's a very interesting paper.
Yeah, it sounds like it. It's like these, when I was down, I was with a friend over Christmas, and she was talking about the transformative effect that this companion app on her phone had had, where it just sort of every time she opened social media, a screen came up and said, do you really want to open Facebook or Twitter or whatever it is? And then it would count down over 5 seconds and give her the opportunity to opt out or not. Now, that wasn't using any of the kind of machine learning that you were describing there, but presumably you could have something like that, which is scaffolding people's autonomy and helping them make informed consensual decisions by learning from what types of things they tend to do accept or not. That's the type of, that's the kind of tech that you were thinking of there, Sarah.
Yes. Yeah.
Wonderful.
Scaffolding is a very good mental picture
Yeah.
of, you still want to give people the freedom to make their own choices, but with the knowledge that we're, as mobile device users, very bad at like taking the time, as mentioned in the chat, like we just click through pop-ups, just like shut up, let me go to the app. And so having to retrain ourselves to be intentional about what we're doing.
Brilliant. Well, thank you so much. What a fantastic talk. What a useful